Okay, let's go ahead and look at these. Iron trioxide is an ionic compound made of two monoatomic ions. So the iron is a +3, the oxide's a -2. We have two irons, gives us a +6, three oxides gives us a -6, so it adds up to 0. For the sulfur and the sulfuric acid, we have to do this one by difference. So we know that we have hydrogen is a +1, oxygen's a -2. 2 times a +1 gives us a +2. 4 times a -2 gives us a -8. They have to add for 0, so sulfur has to be a +6 in order to make that work. We get a +6 divided by 1 sulfur gives us a +6. In the chloric acid, we know hydrogen's a +1 and oxygen is a -2. This says -6 here on this board, and that's the total. Remember, each oxygen is -2. There's a total of 3 oxygens, so we get a total of -6. And then the chlorine has to be +5 total, divided by 1 chlorine is +5. We have that correct on this board. The C6H6, this is one a lot of students get wrong, and nobody did up here, which is good. We know the rules for hydrogen is a +1. There are 6 of them. So we have to have a -6 total for the carbon. There's 6 of those, so that gives us a -1. A lot of times I'll see my students put a -1 for hydrogen because they look at this and think of the metal hydride rule. But carbon's not a metal, so that rule doesn't apply. And then N2O5, we know rule for oxygen is a -2 times 5 is a -10. Divided by the 2 nitrogens means it has to be a +5 for each nitrogen. So both groups did that correctly. All right, do you have any questions on how to assign oxidation numbers? So we can look at reactions and we can see sometimes we'll write in electrons and we can see the electrons being transferred, but most of the time we look at the reactions and we use oxidation numbers to decide what is oxidized and what is reduced. So we're going to look at some equations now and practice figuring out what's oxidized and what's getting reduced. So I have nitrogen gas plus hydrogen gas combining to make ammonia. Like always, the first thing we do is balance the equation. We do that with a 3 here and a 2 here to make 1 nitrogen, 3 hydrogens makes 2 ammonia. These coefficients do not get involved in assigning oxidation numbers, okay? So no information here for oxidation numbers. We just look at the formula. We don't look at the coefficients in the balanced equation. So we can go through looking at this equation and assign oxidation numbers to everything in this equation. So here I have nitrogen gas. Nitrogen is an element in its natural state. Nitrogen is one of the 7 diatomic elements. So this is an element in its natural state, so its oxidation number is 0. Hydrogen is an element in its natural state. Its oxidation number is 0. Over here I have ammonia. So I look at this and I say, well, hydrogen in a compound is usually a +1 unless it's a metal hydride, which this isn't. So 3 times a +1 gives me a +3. This is a neutral compound, so it has to add up to 0, which means I need a -3 here. Divided by 1 nitrogen gives me a -3. So when I look at this now, I say, how did things change? For nitrogen, it was a 0 on the reactant side, and it is a -3 on the product side. The oxidation number went down. It went from 0 to -3. So that